AP Statistics, Unit number 2 on bivariate data, or two-variable data. This is the third problem on the last handout, nonlinear data. So this is number 3. I didn't get to finish this in class, so we'll be finishing it here. So I'll go ahead and get started. Number 3 says, as fans of whitewater rafting know, the river flows more slowly close to its banks because of friction between the riverbank and the water. To study the nature of the relationship between water velocity and the distance from the shore, data were gathered on the velocity, that's in centimeters per second, of a river at different distances in meters from the bank. So that's going perpendicular from the flow of the water in the river. So let's see. A linear regression analysis is given below for predicting velocity using the square root of the distance from the riverbank. So what they did was they took the square root of the distance away from the riverbank, and they kept velocity the same. It looks like they left velocity untouched, but they square rooted the distance. So they square rooted the distance. And when they did that, this is the residual plot. So they didn't show it, and they should have. Good residual graph should show a line through 0. And that is that's the transformation line, which allows us to see whether or not these residuals are randomly scattered about that line. And it kind of looks like they are. It's just one big horizontal blob of points, random scatter. There's no pattern about it. Then it looks like the model's going to be appropriate, the model that they chose. So it looks like they were successful in linearizing the data. It doesn't necessarily mean that the data is linear. It just means that they were able to transform it enough to make it look linear, even though it wasn't linear. Truth is, the original data is nonlinear. That is, the relationship between velocity and distance before they square rooted it will be nonlinear. So if they had to transform one of the variables in order to linearize it, that means the data was already nonlinear to begin with. So letter A, I probably answered. Write a few sentences commenting on the relationship between distance from the riverbank and water velocity. So I'm going to go ahead and say since. Okay, so a couple of facts. The residual plot for the data, transformed data, and let me see, for the data after transforming, distance values to the square root of distance. So the residual plot for the data after transforming distance to square root of distance reveals no pattern or curved nature, I guess you could say. So the data doesn't have a curved nature about it. There's no pattern that's revealed by the residual plot. Therefore, the relationship between square root of the distance and velocity is linear. Or I could say roughly linear, approximately linear, all those are good things. They didn't ask that question though. They didn't ask for the relationship between square root distance and velocity. They asked between just distance and water velocity. So then what am I going to conclude? So if they achieved linearity after transforming either of the variables, that implies the original data set before transforming is nonlinear. So thus, the relationship, I didn't give myself enough room here, the relationship between distance and velocity and that's distance without the square root, is nonlinear. And there we are. So it's an argument that I'm giving. The first thing, residual plot looks great. That's a linear data set. However, I'm going to make a remark. That data set that they are showing a linear pattern for was the transformed data. Transformed data is linear. Therefore, they had to transform it to make it linear from nonlinear. So that means the original data was nonlinear to begin with. There's my train of thought. And that's a very common question. I was saying earlier, we were having a small discussion about like what of this stuff is going to show up on the AP exam. Not much of this mathematical stuff with the exponentials and logarithms. Not much of that. This is what's going to show up on the AP exam. They'll give you something that's already been linearized, and then they'll ask you a simple question. Are these two variables linearly related or nonlinear related? So one of those things. So letter B. Predict the velocity of the river at a distance of 9 meters from the shore. So then that's going to be a math question. This is a very, very common math question on the AP exam. So let's try to get at that. Predict the velocity of the river at a distance of 9 meters. So distance is 9. So D equals to 9 meters. I got to double check that the units agree, that the units are fine. They did, let's see, I'm trying to read that there, because I see velocity in centimeters per second, and then here we go, distances in meters. So that's good. Then I'm going to go ahead with the equation they gave here. A lot of the times, they'll give this to you in a mini-tab output like I was talking earlier. Most of the times, they'll give you like that first title line, and that's going to be good enough. If they didn't give you that title line, you have to look here. This is the value of A, and this is the value of B. Constant is always A. Whatever the other one is, that's going to be B. So square root of the distance. So this is the linearized equation. After they square rooted the distances, so I'm going to use that equation. I'm going to use V instead of velocity and D instead of the distance. So V is equal to 20.1. So I will do expected V, I was writing a vector symbol, equals 20.1 plus 3.01 square root of the distance. So then I'll just go ahead and plug in 9 meters into here. That's going to equal to 20.1 plus 3.01 square root of 9, which is 3. 20.1 plus 3.01 times 3. Calculator should do that really quickly. I'm not looking to try that in my head. And I'm getting 29.13. So they wanted us to predict the velocity of the river at a distance of 9 meters. So the velocity of the river, I'll go ahead and give is expected to be 29.13. I think that's centimeters per second. Let me double check. Centimeters per second is what it says in the problem statement. And that is at 9 meters away from the bank, the river bank, or from the shore. I'll use their words. And that's it for number 3, and that's also it for this particular handout.